Bad. Okay. So, quick roll call. I can see everybody on the screen right now. Okay, Rehan also has joined now. So we have Deep, Dev, Praneeth, Chris, Neil, Prisha, Rehan, Sara, and Sunarka. And we will have more kids joining. But some of you who were not in the class yesterday, I believe that was primarily because of the Holi celebrations. So one last time, happy Holi to everybody. I think I mean Holi is already over, but yeah, I'm probably running late for wishing you guys. Thank you. Hi Dhanushri.
Hi sir.
All right. So we wanted to go back to, I would not say go back. We just continuing with the same unit, which is fundamentals of advanced math, where we talked about the basic trigonometric functions. Then we talked about what did we talk about in the last class? We talked about how do you use a unit circle for getting the different values of the sine, cos and tan. And then we talked about how do we deal with the word problems relating to quadratic equations and expressions. So today we will continue with the same thing, and we'll talk about graphing quadratic functions and polynomials, or exponential functions rather. So we'll look at some of the basic concepts of this. So basically, if you look at this whole syllabus for SAT, right? Even the advanced math is broken into three parts. One is called the fundamental advanced math, then the medium, and then the advanced math. So we'll try covering the fundamental part. Right now we are covering the fundamental part of the advanced math, and that is where we'll talk about the graphing of quadratic equations and exponential functions. And then when we go to the next level, we'll probably talk about things in more detail. Or what I'm thinking is, since we are covering this, we'll cover the advanced math, the fundamental, the medium, and the advanced, and then we'll go to remaining chapters. Okay, as long as that is okay with you guys. Okay, and for you all to be aware, though I follow one sequence to cover the entire syllabus for SAT, but then if you guys ever feel that okay, in my class I'm learning something where I'm kind of struggling with certain concepts, you can let me know a couple of days in advance before the class, and we can cover those topics in our classes later on. Okay, so that way also it'll take care of what you are going through in your classes, as well as we'll continue with our preparation in parallel. Okay, so because if I just continue with my flow and cover all the topics for SAT preparation, I would be able to cover everything in 6 months time. That's what we did when we did one iteration of this. But then you always have the flexibility of asking for certain topics in between, and that helps us stay in touch with what we need to cover as part of our regular classes as well. So that being the context, let's get started. So when we talk about graphing a quadratic equation or a function, what do we exactly mean? So you all have dealt with linear equations, linear functions, and you have seen how do we graph it, right? If I take an example, if I say fx or function of x, which is y, as let's say 4x minus 3. This is a classic example of a linear equation or a linear function, right? If I look at this, this is equation y equal to 4x minus 3. If I look at this, this becomes a function. Function of this is a function of x, where this is abiding by this contract or this agreement. Yeah. And why we say linear? Because the maximum power to the variable x is 1 here. And when you plot that in a coordinate plane, you will see that it plots a straight line. Be it like this or be it like this. Or like this. So necessarily what we are saying here is, if the power to the variable is 1, that depicts or represents a linear function or a linear equation. And why linear? Because that plots a straight line on a coordinate plane if you try plotting it. That understanding is fine, right? I mean, everybody's on the same page. Yeah. Okay. Now, so again, as you all know that okay, if I have a let's say a linear equation like this, and if I try plotting it, very simple approach, right? Nothing fancy about it. What we do is okay, find out that this is a linear equation. If I have to plot that, what I'll do is just by looking at this equation, I know that it's a contract between x and y, which follows this rule, meaning 4 times the value of x minus 3 will be equal to y. So if I keep on increasing x, my value of y increases. Or if I keep on decreasing the value of x, the value of y decreases. That is how it plots line. So the approach that we follow is okay, we'll say okay, what is the value of x and what is the corresponding value of y. You keep on substituting different values and keep finding different values of corresponding value of y. If I put x equal to 0, I get this. I put 1, I get minus 1, so on and so forth. And then we plot this on a coordinate plane, and that gives us a straight line. This part is simple and quite boring because you guys have seen it enough. Now, what happens when we talk about plotting a quadratic equation? So first of all, what is a quadratic equation? A quadratic equation is an equation where the maximum power to the variable x is 2. That is why it is called a quadratic equation. And when you try plotting this, what does it plot? Parabola. Yep. Anybody having a different opinion? Okay, I'm assuming that is a no, and that is how it is supposed to be. So, no matter whether you're talking about quadratic linear equation, quadratic equation, or a cubic equation, or any next level of that, your underlying approach remains the same. If you have a quadratic equation to deal with like this, you will go with the same approach. You will say okay, fine, I will put the different values of x and find out the corresponding value of y, and once I do that, I will go back to my coordinate plane and look at those combination of x and y and keep identifying those points, join them and see what happens. So just to not spend too much time on this one, let me keep a simple equation, very simple equation, so that we can just go with this approach. When I say y equal to x squared, this is also a quadratic equation because the maximum power to the variable is 2. This qualifies the criteria for being called a quadratic equation. You guys all agree, right? Okay. Now, if I put x equal to 0, I see that value of y is also 0. If I put 1, value of y is also 1. If I put 2, this is 4. If I put 3, it becomes 9. How about negative values? If I put minus 1, I get 1. If I put x equals minus 2, I get a 4. If I put a minus 3, I get a 9. And I did that on purpose, so that we get both the flavors of it. Let's see what exactly it means. So, if you look at this value combination and you try plotting that on a coordinate plane. So let's say this is 0, 1, 2, 3, 4, 5, minus 1, minus 2, minus 3, minus 4, minus 5. And here I'll put probably 2, 4, 6, 8, 10. Here minus 2, minus 4, so on, so forth. Now 0 and 0, this is 1 point. 1 and 1, this is second point. 2 and 4, this is my third point. 3 and 9 is my fourth point here. And when I go to minus 1, 1 point. Minus 2, 4, second point. Minus 3, 9, third point. When I join them with a free hand, this is what I get. And this is a parabola. Now you will say this is a kid's play. Why the teacher is wasting time? Because we wanted to double click on this to understand the properties a little bit more about it. Now if you look at it, here in this case, this line is actually, this y-axis is actually splitting this into two equal parts. If I had a different equation and in my parabola was getting plotted here, in that case also there is always a line which splits this into two equal parts. That is called axis of symmetry or line of symmetry, whatever you call it. Meaning it works like a mirror in between, and you see mirror image on both the sides. If you are looking at it from this side, this is the mirror image of this part along this axis. So this is called line of symmetry. Are you guys with me so far? Okay. Now line of symmetry or axis of symmetry, whatever you call it. Now there is another part. When you are looking at this parabola, be it like this, or there could be equations which will flip it upside down. Then in that case also you will have an axis or a line of symmetry which will split this into two equal parts, where both the sides will be equal, exact replica of the other side. Okay. So we saw line of symmetry. This is one of the properties of a parabola. So line of symmetry or axis of symmetry in a parabola is a line, a virtual line or virtual axis which splits into two identical parts, regardless whether it's facing upward or facing downward. Now you must have seen that the way the parabola is plotted always is, on one side it spreads and then it squeezes to converge at one point. This is called the vertex or the 0 point. No, I'll not call it 0 point. I'll call it vertex. Okay. So your vertex could be at the bottom of the parabola or at the top of the parabola, depending on whether it's facing upward or downward. Yeah. Here in this case, where did we see the vertex? It was at the origin of the coordinate plane. Yeah. Now you can see that these are the properties which helps you define or determine where exactly your parabola is. If you know the vertex, so let's say if you have to draw a parabola tomorrow, you have an equation or you just have some clue about how to draw a parabola. You would always think, based on the properties that we have seen so far, let's say the parabola is somewhere here. Let's say if I have to draw a sine curve like we tried drawing, right? What did we do? We said, okay, this is my middle line, and then we have the amplitude here, the amplitude here. So this defines the boundary. So likewise, you always need something as a reference frame or an axis which determines how you will visualize this diagram. So let's say if you just happen to figure out where your axis of symmetry is going to be, that tells you, okay, fine. This is where the parabola will actually have this vertex somewhere. If it's facing upward like this, if it's facing downward, it will be like this. But what you see here is your vertex is always lying on the line of symmetry, because vertex is the lowest point or the highest point, and that has to be on the line of symmetry, because that is how you will be able to visualize this as one side being on in one direction of the axis of symmetry and the other side on the other direction of the axis of symmetry. Is this making sense so far? So see, the point that I'm trying to make here is that your line or axis of symmetry and your vertex are not detachable. You will never have a parabola where your axis of symmetry is here and your vertex is here. That will never be the case. Okay. Now let's dig a little deeper into it. So one thing that we had discussed and agreed so far is that when we have a quadratic equation, then where is the okay. So we just discussed and kind of concluded that okay, if I have a quadratic equation that doesn't draw a straight line, that draws something which is little curvy in nature and which we are calling as parabola. But now, can somebody tell me what is the standard form of a quadratic equation? Yes, Pranit.
X squared plus bx plus c.
Okay. Chris, is that the same thing that you have to tell as well?
Yeah, that's what I was going to say.
Okay. So, if I'm talking about a quadratic equation which will eventually plot a parabola for us, then my most standard form of the equation that will draw a parabola would be this. Okay. Now it's up to us whether this is a standard form of a quadratic equation which eventually draws a parabola for us. Now, what are the things that we need to take into account? What do we see here? There's a term with x squared. There's a term with x and there's a term with c. Okay, c as in only constant. So a is my coefficient for x squared, b is my coefficient for x, and c is my coefficient for x to the power 0, which eventually turns out to be 1. So we will look at these coefficients and try understanding what exactly happens with that. Okay, so let's look at a couple of examples to derive some interpretation from this. So we picked up one equation where we said I have, okay, let me keep it in the corner. I promise I will not delete this. Okay, so this is my quadratic equation. I'm writing it like this. I'll not delete that. Okay, now let's say we have an equation, a quadratic equation with a little bit of variance, where I'll say this is x squared plus 4. This is still a quadratic equation. We see that the maximum power to the variable is 2, which is aligning with my definition of a regular standard quadratic equation, correct? Deep, Prisha, you guys are very quiet. It's okay? Yeah?
Yeah, that's fine.
Yeah. Now, so here, if I just look at this equation and try comparing that with the standard form of a quadratic equation, what do we see? My coefficient a, which is coefficient of x squared, is 1 here. Agree? My coefficient b, which is a coefficient of x, is nothing but looks to be 0. That is how this whole term became invisible to us. Correct? And my coefficient c is 4, because I have a constant 4. Yeah. So let's play with this little bit. So let's look at two equations: y equal to x squared as one equation and y equal to x squared plus 4 as the second equation, and see what exactly happens when we try plotting these two. Okay, so let's say this is y equal to x squared and this is y equal to x squared plus 4. This is x, this is y, this is x, this is y. And trust me, I'm not trying to teach you guys anything. I'm just trying to play with the quadratic equation right now. And I would be very happy if I see you guys playing with this as well. So let's see. I'm looking at two equations, okay? Y equal to x squared and y equal to x squared plus 4. Okay? And we'll just do the same, kids play. We'll try drawing. So in this case of y equal to x squared, if my x is 0, y is 0, 1, 1, 2, 4, 3, 9. And when I go to the negative side of it, minus 1 becomes 1, minus 2 becomes 4, minus 3 becomes 9. So let's say this is 1, 2, 3, 1, 2, 3, minus 3, this is plus 3. 2, 4, 6, 8, 10. Okay, now let's look at this guy. When x equal to 0, this becomes 4. When x equals to 1, this becomes 1 square plus 4, which is 5. When x equal to 2, it becomes 4 plus 4, 8. 1, yeah. When it is 3, it becomes 3 to 9 plus 4, 13. When I go to negative side, minus 1 becomes 1 plus 4, 5. Minus 2 becomes 8. Minus 3 becomes 13. Now let's see, when I'm plotting these two parabolas, what exactly is happening. So 0, 1, 0, 0 is 1 point, 1, 1 is second point, minus 1, 1 is a point as well, 2, 4 is 1 point, minus 2, 4 is another point, 3, 9 is another point, minus 3, 9 is another point. And I'm sorry if you guys are getting bored, but you will see a reason for why I'm trying to get you guys bored. So this is one parabola, this one x, y equal to x square. Now y equal to x square plus 4, what is happening here? When my x is 0, y is 4. So when x is 0, my y is 4. It's here, first point is here. Now 1 and 5, when x is 1, it's 5. Minus 1 is 5. 2, 8. Minus 2, again 8. Minus 3, 13. So minus 3 is 13 somewhere here. 3 is 13 here. If you join these points, what exactly did you see here? Just this coefficient 4, what did it do? Earlier your parabola was starting from the origin. Just by adding 4 to it or the c to it, shifted this parabola upward by 4 units. And that is what I was trying to determine or kind of relay back to you guys, that if you have a quadratic equation, every term that you see here has a role to play. Okay? So this c, the constant term, the c part of the quadratic equation determines which way it will go. So now if I say, okay fine, my equation is not x squared plus 4, this is minus 4. The first thing that will click to you is, oh, my parabola is shifting downward by 4 units. So instead of starting from here, it will start from minus 4, that's it. So the same parabola will shift by 4 points. Is that making sense? Yeah? Deep, Dhanushri, Rehan. And trust me, you don't have to comply with my ask for saying yes. You have to be in agreement before you say yes. Okay? So it's perfectly fine. Sarah, Neil, are you guys with me, Vita?
Yes, sir.
Okay.
Yeah.
So we saw that this is every coefficient that we see here has a role to play. And again, I'm saying every, but I have showed you guys only one. Only the C part I have showed. When you have a constant, if you put a plus or a minus, that determines whether it will move upward or downward. So in case of plus, it will move upward. So let's say if your parabola was starting at, not every parabola starts from origin, right? Let's say if you are based on the equation, your parabola is here. Let's say which was y equal to 2x squared plus 6x minus 7, let's say. That was the equation, and that was plotting this parabola. I'm just making it up. Now, if I have another parabola where I'll say, okay, fine, I will just move this part by whatever was this thing, I will add another 10 to it. So minus 7 becomes plus 3. So essentially what you're saying is your vertex will move by that many points, 10 points. It moves here. So the parabola starts from here. Everything else remains the same because you just change the C value. So your C value determines the upward or downward movement, yeah, of the parabola. And again, when you're talking about moving something, right, you pick up a point and you move that point so that everything else shifts, right? If let's say if you have to move me, you'll probably hold me by my neck and say, okay, move to the right, correct? So same thing here, you're holding the vertex and then you're moving that, depending on how this constant, the C, the coefficient C is getting played around with, yeah. I know you guys did not like the idea of moving me by holding my neck, but I'm just giving a reference, okay? And you guys, sometimes you guys can laugh if my joke is worthy enough. It's okay. Alright, now coming back to this one. So we saw what is the role that C plays in a parabola. Let's look at other aspects also. Let's look at two situations where we have two different quadratic equations, and this time we'll play with A part of it. Let's say I have a quadratic equation y equal to x squared minus x squared, and second equation is y equal to x squared. And I'm purposefully picking up simple equations so that we don't end up spending a lot of time determining or doing the calculation, okay? But it should at least help us get the concept right. Now if you look at these two equations, both are quadratic equations, no disconnect, right? Now the only observation that we are able to make here is there's a difference between these two. In this case, here my A is equal to minus 1, and in this case my A is equal to 1. Let's try to understand what exactly happens when I'm dealing with a coefficient with negative value versus a positive value. Okay? Are you guys with me? Okay. Now, I will not do anything fancy. I only do easy stuff. This is y equal to x squared and this is y equal to minus x squared. Okay? So, you guys keep on getting logged out every 10 minutes. Alright. So here, let's look at the situation. X, Y, X, Y. This time I will not pick up 8-10 points, I will probably pick 3-4 points or 5 points maybe. So in this case, when x equal to 0, 0, this is 0, 1, this is 1, when this is 2, this is 4. I'll pick minus 1, so minus 1 square is also 1, minus 2, that is also 4, plus 4 only. Here in this case what happens? When I go for x equal to 0, this becomes 0 square minus, doesn't make a difference, I can put 0. If I say x equal to 1, this becomes 1 square, that is 1, and minus to it, so that is minus 1. 2 becomes 4 minus to it, minus 4. When I give minus 1, this again becomes 1 and a minus to it, that is minus 1. When I give a minus 2, it becomes 4 and minus to it, that is this. So now, if I look at these two situations, there is some observation that we can make by looking at it, but let's plot it and not try assuming anything. 0, 0, 1 point. I'm just assuming some points here, okay? I'm not making it look cluttered. 1 and 1. Let's say this is 1, this is 1. So I'll say this. Minus 1 and 1 will be on this side. 2 and 4 will be somewhere here. Minus 2 and 4 will be somewhere here. If I join these 2 points, this is my parabola. Now what happens in this case? This is my parabola 1. or y equal to x square. If I go to this guy, 0, 0, this point, perfectly fine. 1 and minus 1. 1, x is 1, y is minus 1. So when x is 1, y is minus 1. I'm talking about this point. 2 minus 4. When this is 2 minus 4, it's here. Minus 1 is also minus 1. So when it's minus 1, this is minus 1 here. Minus 2 is minus 4. Now this is your parabola. What happened? You made the parabola flip. Yeah. You had $500 and let's say your friend had $500 and you said no. Now you have negative $500, meaning now you owe me $500. Obviously, somebody will get upset. Flips upside down. That was a lighted part of it. But on a serious note, what you see here is when your coefficient was positive, the parabola was facing upward. When your coefficient was negative for x squared, or the value of a was positive, it was facing upward. When the value of a is a negative value, it's facing downward. And that's an interpretation we can draw from this. So there are two things, two interesting behaviors we observed. One was your C makes your parabola move up or down. If it's positive, it moves up. If it's negative, it moves down by that many points. If you have a negative coefficient, the parabola is facing downward. If you have a positive coefficient, the parabola is facing upward. Are these two concepts that we have seen so far easy to relate, easy to understand, and would you carry with you, would you carry these concepts with you for the rest of your life? Yeah? And again, see, the point that I'm trying to make here is, did I do anything fancy here? No. It's all about knowing the basic concept and seeing it visually by ourselves. So we just visually saw it to derive interpretation out of it. Yeah. So we saw what is the role that A plays, what is the role that C plays. Basically, when I'm talking about A and C, I'm essentially referring to a standard form of the quadratic equation and seeing what is the role of A and what is the role of C. These two we have observed just now. Any questions? So let me do one thing. I can cover this whole topic in 2 classes, but I would not do that. The reason being, I knowing it is one part of it, you guys knowing it is second part of it, and the third part is how much practice we are able to do with those things, those concepts. So let me give an equation here, a quadratic equation which says 3x squared plus 4x, or I'll not give the x component to it for now, okay, plus 6 is one equation of a parabola, and a second parabola is 3x squared plus 2. I want somebody to explain me what is the difference you will see with respect to this parabola without solving for it, okay? Because we have just seen the concepts ourselves. I would want somebody in the class to explain me, by looking at these two equations of the parabola, what would be your interpretation and how would you want me to be aware of the difference between the two parabolas in terms of we seeing it in a visual coordinate plane. Give me some story. I want to understand how do you give the narrative if you have to explain this to me now with whatever we have understood so far. And it could be anybody. Yes, Prisha.
Would they start at different spots?
You are the teacher right now. You have to tell me. I'm changing my hat. I'm trying to behave like a student for next 5 minutes.
I think that they're gonna start at different spots.
Different spots. Can you be a little more explicit?
Like the first one
Mm-hmm.
will start at like 6 on the y-axis.
Okay. So, see, we have not done any scratch work, right? We haven't got our hands dirty yet with this one. We are trying to derive some interpretation by just looking at this, correct? Now, what did we see was this. What did we see? That the C makes the upward or downward movement, correct? Meaning, if my value of C is higher, let's say my parabola is here, my coordinate plane is here, okay? If my value of C is higher, meaning the vertex is at higher point. If my value of C is lower, this is a lower point. So this is essentially depicting how is the vertical displacement happening for this parabola based on the value of C. So when you just look at these two equations and think through it, your guidance to me would be that Viren, you have to look at your coefficient of x squared is same. Sorry. So it's going to plot similar parabola. The only difference that will come into play by looking at the C part of it is that one is vertically higher, one is little below. And interestingly, your axis of symmetry will be the same. So this will be moving along the axis of symmetry by 4 points above and or 4 points below. Is it making sense? Yeah. Chris, Rehan, Neil, Sarah, anybody having a different point of view or something that is sounding confusing or gibberish? No? Sunarka? Are you with me, beta?
Yes, sir.
Okay. So basically, before I started the class, right, I was thinking that how do I navigate you guys through these concepts? Then I thought, beauty lies in simplicity, right? So I'm just trying to go in a very simple approach without making you guys worried about the complex aspects of it. Whatever we have done so far, there was nothing fancy about it. We just, like any equation, it's a contract between the variables. So we picked up the equation, regardless whether it's a linear equation or quadratic equation or whatever, and then we plotted that. And from that plotting, we have tried deriving some interpretation. Now, let's look at a third scenario. We have talked about two of the coefficients, A and B, in the quadratic equation. So, since I erased that, let me write it one more time for you guys. This is my standard form of the quadratic equation. So, now we are very clear about the behavior of A and C, or the kind of influence these two coefficients bring to quadratic equation, correct? Yeah? Dhanushri, Deep, everybody with me, right? We clearly know what is the influence that these two coefficients bring. Now, what we don't know about is the B. Let's see what B does. So, let's look at two equations. Y equal to x squared. This is one equation, okay? And then I will say y equal to x squared plus, let's say, I will say x for now. And see what happens here. This is my first table, y equal to x squared. This is my second table, y equal to x squared plus x. And I'm doing boring stuff because that is how you guys will be able to relate it better. I'm not saying that you guys are boring, but probably as a teacher I'm a little boring. Okay. Now let's look at 5 points in both the graphs. Okay. Let's identify 5 points for plotting both the parabolas. Obviously, both are parabolas. That there's no denying that, right? Because both have maximum power is 2. Yeah. So let's look at y equal to x squared scenario. 0, 0, 1, 1, 2, 4, minus 1, 1, minus 2, minus 4. Now look at this guy. 0, 0. 1, it becomes 1 plus 1, 2. When I put 2, it becomes 4 plus 2, 6. When I put 3, it becomes 9 plus 3, 12. When I put, I'll not go to my 3, let me go to the negative side of it. So when I put minus 1, it becomes 1 square, 1 minus 1. 1 second. Okay, so when I'm putting minus 1, it becomes 1, 1, this is 1 and this is minus 1, this becomes 0. Okay. Then when I put minus 2, it becomes 4 minus 2, that is 2. So something has changed here. Let's see. First one, 0, 0, 1, 1, minus 1, 1, 2, 4, minus 2, 4. This is my first parabola. Okay. Now here in this case, 0, 0, this is one of the point. 1 and 2. So when this is 1, x is 1, y is 2. 2 and 6. When this is 2, this is 6. Probably here. Minus 1, minus 1, 0. Minus 2 gives a 2 here. And you will realize that when you draw this, this guy has gone below this. Okay, this guy has gone below this x-axis. Why? Because you had a situation like this. Now you'll say why. Let's look at one situation. There's one more term that we did not learn about, and I was keeping that in my reserve so that we'll pause it here now, because we saw that when we are looking at b, when we are looking at the x coefficient of x, something is not little different. This guy moved a little bit down here. Now we talked about the axis of symmetry. We talked about the vertex, but we did not talk about how do you find out the vertex, right? So your vertex is always, when you're looking at let's say a parabola, your vertex, if the parabola is facing upward, your vertex will be the lowest point. Okay, that is called the 0 point. That is called the 0 point, meaning do we call vertex as the 0 point, Praneeth? Do you recall?
Groups, zeros. No, wait. The vertex only.
Yeah, I think we call, I mean, I'll just check the term actually. I am forgetting the term though. But when you are looking at a vertex, okay, vertex is always the lowest point if your parabola is facing upward. Okay, so whatever be the coordinate of this point, x and y value, that will be the vertex. Now it will be the lowest point, meaning the lowest value of y. Yanil.
I think it's called the minimum when it's
Minimum point, yeah, that's the term I was coming to actually. So when I was thinking through it, I could collect that. Now the vertex is the minimum point if it is facing upward, or the vertex will be the maximum point if it is facing downward. Now this vertex, there's a minimum point, there's a maximum point, and there's a 0 point also. Now you'll say, what is 0 point? 0 point is where the value, okay, this is your parabola. this is your outcome based on this input. This is the output based on this input. When you say 0 point, you are essentially saying when the value of y is 0. When will the value of y be 0? In any equation. When it touches the x-axis, right? Every point on this x-axis, the y value is 0. Yeah? So, if your parabola ever touches the x-axis, okay, or the points where it touches the x-axis, that is called 0. The 0 point, meaning the point where the value of y will be 0. Okay. So in this scenario, what we are seeing is, if you look at this one, second one, there are two places where your y value is 0. There are 2 0 points, yeah, or 2 zeros for this parabola. Meaning there are two places where this parabola is touching the x-axis or intersecting the x-axis. So now imagine this one without thinking about mathematically. Yeah, if you have a parabola, if you are talking about where it's touching the x-axis or how many ways it can touch the axis. In this case, it's not touching the x-axis. There is no intercept. So there will not be any 0 for this parabola. If you are looking at this parabola, if you are looking at the second parabola where it just touches at one point, like in the first case, this one, this has 1 0 point, meaning there is only one value of x for which the y becomes 0. Yeah? And there could be a third scenario where it can touch two places, where it can touch the x-axis at two places or intersect the x-axis at two places. That is the scenario we are talking about. Okay. So here in this case what we saw was there were two possible values of x for which I am getting the y value as 0. Okay. Two values of x. When x is 0, you are getting y equal to 0. When x is minus 1, you are getting 0. So by looking at this information, what we interpret is that in this scenario, my parabola is actually going below the x-axis, because that's the only case when you can have two zeros, okay, or 2 0 points. Because if it's not going below this, by no means you will have 2 zeros for this parabola. So going back to what we have done so far, right? So we talked about what is the role of A and how A helps you figure out whether it's facing upward or downward. What is the role of C when it ensures the vertical movement of the parabola by pulling the vertex up or down. And we are looking at the third situation where we are trying to determine what is the role that B plays. And when we are doing that, we came across another concept which we have not covered, that is called finding zeros of a parabola or the minimum or maximum point of parabola. So let's come back to that before we go deeper into B. Okay? Are you guys able to follow me so far, or I'm kind of getting you guys more confused? Rehan, Deep, Chris. Yeah? Okay. So again, Snarka, everybody okay? Yeah. No, so again, when I'm teaching something, right, I would always want you guys to challenge me, prove me wrong, because there could be times when I will just overlook something and then continue and then probably get you guys more confused about the concept. So if I am having an oversight and I'm just missing on some concept, or if I'm doing some wrong calculation, if you guys stop me, I don't take it bad, okay? I mean, it's perfectly fine, because I would not know the concept, but when I'm applying things, I might make mistakes, and that's very normal, right? Don't hesitate to ask about it. But yeah, coming back to the parabola. So now we have seen that, okay, if I have a parabola, we know about which splits the parabola into two identical parts. That is one thing we learned. The lowest point is called the vertex or the minimum or maximum point. So you can call it vertex in general. But if your parabola is facing upward, then this will be a minimum point. If your parabola is facing downward, this is still your vertex, but this is your maximum point. Meaning, this is the point where the y value will be maximum in this parabola. Yeah. Another thing that we learned was that a zero of a parabola means the point where the parabola touches or intersects the x-axis. Zero of a parabola. Zero. Y is representing the parabola, right? In this quadratic equation form. So zero of a parabola means when y is zero. So that will help you determine what are the points where it's touching or intersecting the x-axis. So there are three scenarios that we can think of. One is when it's not even touching or coming closer to the x-axis, so there will be no zero. One scenario when it touches the x-axis at only one place, there will be 1 0. And third scenario is when it crosses and goes further below, so it has 2 points. So when you have 2 points when it's intersecting, then what we are trying to say here is, if it's a parabola which is facing upward, then my vertex has a y value negative. Or if you look at it pictorially, right? Let's say there are 2 points, x1 and x2. This is where the parabola is intersecting the x-axis. Obviously, the coordinates of this will be x1 0, x2 0, right? Because it's anyway the x-axis. So here, if you look at this part, just going by the symmetry, what you can see is the x coordinate value of this point will be nothing but average of this. Yeah. And y value will be a value which is negative, and that we'll have to determine. Okay. So this point is falling on this one. So once you find out the x value, you substitute in this equation and you'll find the corresponding y value. So this is how you can determine the x and y coordinate of the vertex of a given parabola. Okay. So far we have not come to B, and there is little more trick involved. That's why I'm purposefully holding on to it. Okay. We'll come back to the interpretation of B and what role that B plays in the manipulation of the parabola that we're talking about. Any questions so far? Any free flow of ideas, any concern, question, query, doubt, ambiguity that you want to call out? No? So let me ask some random questions just to see what is your way of looking at things. If I'm talking about a parabola facing downward, okay, can I have the vertex with y equal to 0? I mean, can I have, if I have a parabola which is facing downward, can it have its 0 and vertex matching?
Oh.
Sit down. There's a class going on. Okay. Now, second question to you guys is, if I have a parabola facing upward, can I have the coefficient A has positive or negative? Yeah, Pranay.
Positive.
I'm sorry?
The coefficient A has to be positive.
Always. That's a thumb rule. So let me touch upon one more concept because we have 3-4 more minutes. Okay, let me not rush through it, but okay, let me talk through the concept quickly. So there is a concept called intercept. Okay, now when you talk about intercept, it simply means when you are intersecting something or touching something. That's, pick a chair and sit down. You can sit here, you can sit here. So if I have a parabola, what are the possibilities we are talking about? It can have, in this situation, it is intersecting y-axis at one place. It's not for you guys, okay? You just listen to it. This is more like music to your ears, don't worry about it. Okay? When the parabola touches or crosses the y-axis, that is called y-intercept. The point where it touches the y-axis, that is called y-intercept. The places where it touches the x-axis, that is called x-intercepts. Okay? Now, this is the visual part of it. If you look at a parabola, let's say y equal to x squared plus x, the same example. If I have to find out the y-intercept, where will it touch y-axis? Wherever it touches the y-axis, my x value will be 0. Okay? Guys. Wherever it touches y-axis, or if I'm trying to find out the y-intercept, meaning the point where it touches the y-axis, my x value will be 0. When x is 0, that is where touching the y-axis. So you have to put the value of x to find out the y-intercept. Here in this case, when x is 0, y is also 0. So that means this is touching it at the 0, 0. Similarly, if you have an equation like this and you have to find out the x-intercept. X-intercept meaning where it touches the x-axis, meaning your y value has to be 0. And that is what you will always solve for. So it's okay. Y, we have to find out the x-intercept, meaning where the y-axis, y value becomes 0. So that means this value becomes 0. So x squared plus x becomes 0. That means x into x plus 1 becomes 0. That means x equals to either 0 or x equals minus 1. That is what we saw in the previous example that we were trying to solve. This is your x-intercept. And if it's touching at two places, that means your vertex is going below your x-axis, and we'll play with that in the next class. Okay? So there's a lot of interesting facts that we would need to learn about parabola, and those are all relatable. There's nothing coming out of the blue. These are all the concepts that we derive by playing with this, and we'll talk about that in the coming class. So with that being said, if you guys have no further doubts, I will let you guys go and use the time whenever you get to do some unit test on Khan Academy, because that's your place where you can do some sums to reaffirm that whatever you have learned, you are able to apply that with the kind of questions that you are going to come across in your tests. Any questions you guys have before I let you guys go?